Hello guys, what you see here is again a 2x16 LCD. So this time we have interfaced 2x16 LCD to EFM32GG12, which is a 32-bit giant gecko microcontroller from Silicon Labs. So you can see here the four wires that are coming out. These are the data bits, so which we have interfaced to P8, 9, 10, 11, and then the three control pins, the register select, read write, and then enable pins are pulled out. And what we did is because this board is uh, like little small, right? We don't have the connectors mounted on this. This is a low cost board, so for that we just took another board, the MSP432 board, and tried to pull down 5 volts from that. And you can see here the display is showing up. So this is how the connections are made. Very simple connections, right? Just 4, 7, 8 connections along with supply, and the display is up. We'll just look through the code to see how it is working. This is the Simplicity Studio. So we are using Simplicity Studio for writing code to EFM32GG12, right? These are the three function declarations at the top, where we have LCD command, LCD data to be written, and then delay. So here delay again, as with the other codes we have written previously, we did not use timers. We just used approximate timing by using the for loops. And then we have just put a string here, and then apart from that, these are the standard API definitions, initialization definitions from Silicon Labs. So post that, we just try to introduce some delay, and then if you see here, we are setting the pins RS, RW, and enable to output. So they are set in push-pull mode, and we are using PA0, that means port A0, and PA1 and PA2 for the control segment. So we are using the inbuilt function GPO pin mode set. So this is the prototype of that particular function. So you can see here, it needs port name, it needs pin name, and then what is the type of mode we are setting, and then the output. So if you see here, this is the port name we are given, and then the pin number PA0 we are using, so that is the pin number, and then the mode. So if you go to declaration this, so you can see here, this is the type def enum defines the GPO mode push pull, and then if you want to select your pin as input or output, or if you want to disable, so you can use any of this. So this is inbuilt into the library that is provided by Silicon Labs, so you can use that. So, and then post that we are using P8, P9, P10, P11 as the data pins, which are connected to D4, D5, D6, D7, which was shown in the video before. And then post that this is a basic initialization sequence. This is what we follow. And one thing is we have to select the 4-bit mode, because we are using only nibble here. We are not using the entire byte. And then we are just trying to push the data to the LCD, and then we are moving to the second line. Initially we are on the first line here, and then we are moving to the second line, and we are pushing the way to know. So this is how it is done. And then if we go into the LCD underscore command, this function, so actually we are only using a nibble here. So that means we have to extract the lower nibble and upper nibble from the byte value of this command, and then push it over the four data lines, right? So for that, if you can see here, initially we are extracting the upper nibble, by performing the AND operation on the value, and then so this PE0, PE8 are on the third nibble, right? If you take 0 to 3, 4 to 7, and 8 to 11, so these are the third nibble. So considering that we have upper nibble here, so we have shifted the command value by 4 times so that we move to the third nibble, and then we are setting the value. So if you see here, this function, this function has to have parameters of port number, that means port E, which we are using, and then the value, and then the mask. So this is called the mask which we are giving. So where the data need to be inserted. And then this is again the standard sequence. We are trying to clear the port A, the RS bit, and then we are 0th pin of RS bit, and then we are clearing the read write bit and enable high to low. So for the data to get onto the LCD, and then so once the upper nibble is written, now it is a turn of lower nibble. So you can see here the lower nibble. Here we are using 0F, and then F will be here. So we are shifting 2 times. That means 8. Okay, and then we are pushing the data. So this can be written in a better manner as well. We are just trying to experiment a little around this for easy understanding. So that's why I say similarly, once command is done, so data also it's the similar way. You can see here pushing the upper level and the lower level. So that is how it is. We are not performing any continuous operation, so there is nothing here. It's like written in a very simple format, easy to understand format. Please check it out if you have any questions. So also we have put a link to our blog where we have mentioned the pin mapping for your convenience. Please go through it and let us know if you have any questions. And as we mentioned, this is for EFM32GG12 Giant Gecko 32-bit microcontroller series. And previously, the same LCD has been interfaced to MSP432 as well. Just check out our videos, and please let us know if you have any questions. So one important point, if you are using for your main controller, as we have mentioned during MSP432, the delays you have to adjust. So if you are using a precise delay, like introducing a timer and all, I think that is the best thing to use. Otherwise, you can for hobby purpose, you can randomly use a delay and try to run the project. Thank you. If you like our video, please do watch it, and please post your comments definitely, and subscribe to our channel. Thank you.